morning. Today is Thursday, the 4th of March, and we are going to be exploring and calculating exterior angles within a polygon. So we touched upon some of this language yesterday, so if you need to make yourself more familiar with the word polygon, please have a look back at yesterday's videos to remind yourself. Today we need to look at the difference between interior and exterior angles, and we looked at the beginning of that yesterday, but we will refresh our memory on that today. And then we need to know how many degrees there are within different sided shapes using our help sheet and using the formula that we were talked through yesterday. So at this point in the lesson, you should have had a chance to complete your arithmetic practice, and then we can go straight into our main learning. So if we just look at this language of exterior angles, we're talking about angles which are outside our closed shape. So yesterday we were focusing on the interior angles. Today we're looking at the exterior angles. So it's just, you can see the difference between the two using these two diagrams, that we're going to be talking about exterior angles on shapes today. So you're going to come across problems like this where it's asking you to find the missing angle. So that's the first thing we always need to look at and come across. So we've got here that we're missing the angle X, and we need to calculate what that might be. So we have got some information about the interior angles of this right angled triangle. Obviously we know that it's a right angled triangle because it's got that special symbol in the corner. So we already know that we are dealing with a 90-degree angle at this point. And if you can remember and refresh your knowledge from yesterday, that if we added all the interior angles up within a three-sided polygon, we will find that the total number for an interior angles totals up 180 degrees, and we formed a straight line with that when we did some cutting and sorting yesterday. So that's our interior angles, and actually on this shape we have all that information. What we don't have is the information about the exterior angle X here, but we can see, and you should already be able to notice, that we're on a straight line, and we know something about angles on a straight line, that they all equal 180 degrees. So our total, if we were starting to form our bar model, we've got, oh, I apologize there, I'll just make that a little bit straighter for you. So our hole here we have is our 180 degrees for our angles along a straight line. So obviously it's the interior angles as well, but we're talking about these angles along straight lines, this bit here. And we already know, if we're looking at forming our bar model, we already know one of the angles, and our job is to work out what the other angle is. So we already know our acute angle here at 45 degrees. Missed my degrees up here. But we are missing our X here. We're missing this missing angle. So it's a very straightforward one, really. You have some information. You can, from your hole, take off that part and find the other missing leftover part, that the last angle that will create our straight line angle, which is 180 degrees. So if we do 180 degrees and we subtract our 45 degrees, we will find what we are left with in our calculations. We've got 180, take away our 40, and then take away our 5. So we can see that we've got 135 degrees. So our missing obtuse angle here is 135 degrees. And we can check that, because if we put that back into our bar model, I put it back in brown here, 135. If we added 135 to 45 degrees, then we will get back to our straight line angle, 180 degrees. So we have this problem which gets a little bit more complicated when we're asked to investigate the exterior angles of these shapes. So we're still looking for the exterior angles, and as you can see we've got one missing here. But before we even get to that point, we've got a first step to this problem to solve before we can get on, because we don't know our missing angle here. So we need to find that out in order to work out this missing angle. And in order to find our missing angle here to start off with, so we could almost label this a different letter, I'll label that B if you like. We need to use our knowledge of the interior angles of a triangle. So we know from our previous knowledge that 180 degrees is the total number of interior angles on every type of three-sided polygon and every type of triangle. So we already now know some information, and we can work out that missing part that we need to be able to be successful at the second bit of our problem. So if we've got here, we've got our 70 degrees that we already know, and we've also know that there are 80 degrees known to us, and we are missing our information about this part, this angle here. So like we have done before, we will need to work that out. Firstly, we will need to work out if we have these two totals put together. So if we have our 70 plus our 80, we can then know how much we're going to be taking off our total to find out what is left. So if I just here, if I put here a bit of a brighter colour so you can see against the blue, if we're doing 70 plus 80, we should recognise that we are going to be at 150 degrees that we already know about. So we can almost put that information onto our bar model, that these two sections together will give us our 150 degrees. Just about fit that in there. And from that, we can also work out what B will be. So if we do 180 and we take away 180 degrees, sorry, we take away 150 degrees from that, you'll already be able to spot what that might be. So we're doing 180, take away 150, we get 30 degrees left over. So we're dealing with a little acute angle there, which is our B. So if I put that back in our equation, so we've got here is 30, and we can put that back in our diagram here, being 30. So now we have all the interior angles. We can always check that, because obviously we can put that back in the original adding. So we could do 70 plus 80 plus 30, and it give us our total interior angles totaling up to 180 degrees. Then we're going to be using the same information to transfer onto a further bar model to explain what we're going to be doing. So we're now looking along another straight line here. Now, it doesn't matter that the paper's orientated slightly differently. As I've said quite a few times now, you can obviously turn your paper around. You can see that that is a straight line there, even though it looks a little bit different. So you've got your straight line, and we know that angles along the straight line equal 180. So we've got our total, and we know that's 180. We already know what B is, because we've just calculated that in our first step of our problem, and that was 30 degrees. And our next job is to work out what is the missing information to find out the A, this angle here. So if we do 180 degrees and we subtract 30 degrees, you should already be thinking, oh, I know what that one's going to be. We have our 150 degrees. So we know that A on this diagram here is 150 degrees. So if I put in my measurement 150 degrees here, and I can always check this because I know that this obtuse angle and this acute angle together should give me my angles along a straight line, which is 180. So if I've got 150 and I add on 30, then I can find out that I have got back to 180. So I know that that angle, the missing angle here, is 150 degrees. regular shapes, you should already be able to see that this is a regular pentagon. We know it's regular because it indicates to us that all the sides are equal. I think there's a missing one there, but we've got a regular pentagon. All lengths are equal on the sides. And therefore, we know because it's a regular pentagon, all the angles are going to be equal as well. Now, this is where you might be thinking, oh, I'm going to go back to my help sheet to find out the interior angle total of a pentagon. Or you might be thinking, okay, well, I'm going to calculate it using one of the formulas that I was working on yesterday. Either or, you should have remembered, or you need to refresh with your formula, that the total of the interior angles of a pentagon is 540 degrees. So that marks our hole that we are thinking about. And you can see that we have got this divided into our 5 interior angles. So if we divide that number by 5, we'll find out what our individual angles are. So we would be doing that on the bar chart to find out this one. Now, we haven't given this one a label actually at the moment, so we could label that one a different letter. We've got P here that we're eventually getting to. It's another 2-step problem. So if I label this A, so we're just knowing we're looking for A first before we can find out P, sorry. So if I separate this out here, so I've got one, it's not as accurate as I wish it to be, it's trying to get the equal, because these are going to be equal in size, these angles. 1, 2, 3, oh, I always do that wrong, 4. Okay, so I should have 5 equal parts. And if I can use my knowledge of my help sheet to know what of a regular pentagon, what all of the interior angles will be, I should already remember that it was 108 degrees. I could also calculate that if I did my formula. A, we've already established, because one of the interior angles of this regular pentagon is 108 degrees. But we're not looking for A as our end result. That's almost our step 1 of this problem. We are looking at finding out what P is. Well, we can see it's along a straight line. We already know our obtuse angle is 108 degrees, and we're looking for the last part of our diagram. So I'm just going to be the situation that we're dealing with. I'll try and do it all in kind of a green color so that you can see where I'm thinking about. So I'm in part 2 now. And my hole is 180 degrees along my straight line. I'll just indicate to you what straight line I'm talking about, which is this one here. Not very straightly drawn. But we know part of the angles on our straight line, and we know one of those angles being obtuse, being the larger of the two actually. And we know that is 108 degrees. This is my degrees up here. Just a bit small. So I'm looking for what P is. So if I'm trying to find out P, I'll do my workings up here, crunch to get everything in. So if I do 180 degrees and I subtract my 108 degrees, I will find out what I am left with in order to find out what my angle at P is. So I'm going to do my 108 degrees, and I'm going to take away my 180 degrees, take away my 108 degrees, and I will end up with 72 degrees. Now I can see, however to scale or not to scale this diagram is, you can see that that is a smaller angle than the first along the line. It's an acute angle. So if I'm looking at my 72, well, I think I'm on the right track with that because I've got the correct answer there. So therefore I know that this is 72, and I can check that by, if I was adding together 108 plus 72, I will get back to my hole 180. So I know back on my diagram, I can do my second step now and fill in the information I was actually finding at the beginning, which was what was at the missing angle P. So there's quite a few steps to go through to get that bit there. So that marks the end of today's session and the more complex exterior ways to find the angles on some of these shapes where you might need to do 2 steps. Once you finish, please send in your work to your class teacher, and you will be you'll find the answers to the questions at the bottom as normal. So goodbye for now, and see you tomorrow.